Hi, students. So today we are going to work on section 7.5, which is solving equations with rational expressions. Okay. So what we did in 7.4, we didn't have equations. We were just adding and subtracting rational expressions. So our only tools was really that trick to multiply by versions of 1. Okay, but now we want to actually solve an equation. So we're going to have an equal sign, and that equal sign says that one side of our equation is equal to another side. Now, of course, we have variables here. When we solve equations, our goal is to figure out the value of the variable that makes the equation true. Essentially, the value of the variable that makes both sides equal. When we have equations and solve equations, we kind of have a little more, we have more tools in our toolkit, essentially. So what the tools in our toolkit are, anytime that we're solving equations, we have these properties of equality. And let me show you the properties of equality. Okay, so here, a lot of the properties of equality you probably already know, and they intuitively make sense. So A is equal to A, or if A equals B, then B equals A. So you may have seen equations and think they kind of go one direction, but really they go both ways, right? That equal sign goes in both directions. The transitive property says that if two things are equal, and one of those things is equal to a third thing, then the first and third thing are also equal, okay? The properties we really use a lot are going to be the property of addition. So if both sides of your equation are equal, as long as you add the same thing to both sides, it's going to maintain that equality. The same goes for subtraction, and the same goes for multiplication and division. You just need to be careful when using multiplication and division here. You have to multiply or divide the entire side of the equation on both sides. So you have to be very careful that you're not just multiplying part of each side of the equation. So you got to multiply and divide the entire side of both sides of your equation in order to maintain that equality. So usually if you're going to multiply or divide by some number on both sides of your equation, it's a good idea to put parentheses around both sides of your equation and then write in the multiplication or the division, okay, to make sure that that gets distributed to every term in your equation, okay? Also, there is substitution, where if two things are equal, then at any point, we could replace something with something that is equal to it, okay? So those are the properties of equality, and we get to apply these properties of equality when solving equations, and we can't apply them in other places. They really allow us to do whatever we want to our equation as long as we do it to both sides of the equation, okay? In addition to these properties of equality, we can still use the same tools that we had when we were adding and subtracting rational expressions, which means it's still fine to multiply by versions of 1 anywhere inside our equation that we want, okay? So now we have kind of both those tools, and our goal is to solve these equations. So now that you've seen those properties of equality, let's get to an example. All right, so our first example is going to be x minus 5 over 2 is equal to x over 7. Okay, so this is an equation and it contains rational expressions, just meaning that it contains fractions with variables, okay? So what we want to do here is solve for x, and we get to use all of our tools, including the properties of equality, because we have this equal sign. Okay, so what we can do, usually a good technique is to get rid of your fractions first. Okay, so in order to get rid of our fractions here, since we have a denominator of 2 and a denominator of 7, if we want to get rid of this denominator of 2, it means this whole side is being divided by 2. We need to multiply by 2. And over here, if we want to get rid of this denominator of 7, we need to multiply by 7. But remember, we can't just, do things by magic. We have to maintain this equality. We want both sides to stay equal because that's the only way our resulting equation will tell us what x is equal to. So that just means whatever we do to one side, we do to the other side. So in this case, we're going to multiply by 2 and we're going to multiply by 7, and we're going to do it on both sides. Okay. So I'm going to take this whole side here and I'm going to say I'm going to multiply it by 2 and multiply it by 7. Okay. And on the left, I'm going to take that whole side there. I'm going to multiply it by 2 and I'm going to multiply it by 7. All right. Now in doing so, if you remember how multiplying fractions works, you can maybe right now see that we can cancel out our 7s and we can cancel out our 2s. Okay. If that makes you uncomfortable, you can go ahead and rewrite both sides of your equation, which is going to be 7 times 2 times x minus 5 all over 2 is equal to x times 2 times 7 all over 7. And remember, now each thing in parentheses in the top is a factor. And so if things match in the top and the bottom that are factored, we can cancel them out. So that's how we get to cancel out that 2 and cancel out that 7. Okay. That's the first step to solving equations that have fractions in them. There are other techniques, but it's really easy. Once you get good at just get rid of your fractions, and then it makes your equation a lot easier to deal with. All right, so now that we've done that, let's take a look at what we have left. So now we have a 7 times x minus 5 is equal to a 2x. So that's our x times 2. So see how by multiplying both sides by all our denominators, we were able to get rid of the denominators. Okay. So now that we just have this, we can distribute and see what next property of equality we should use. So we've got 7x minus, what is that, 35 equals 2x. Now we're going to use the additive property of equality to try to get all our variables on one side, all our constant terms on the other. So I'm going to subtract 2x from both sides to get all my variables onto the left-hand side. So now I've got 5x minus 35 equals 0. And then I'm going to add 35 to both sides. And then I'm going to get 5x equals 35. Let me get rid of that little piece of. So now we've got 5x equals 35. And from there, we're going to use multiplicative and division property of equality to just divide both sides by 5. And we will get that x equals 7. So we've got 5x equals 35. We divide this side by 5, and notice we divide this side by 5. Notice how, because I'm using the fraction bars, it already groups that whole side together. So you can use fraction bars if you want. That's probably the best way to go, is to use fraction bars versus putting everything in parentheses and saying divide using that division symbol. You want to get comfortable just using fraction bars all the time and moving away from that weird division symbol. Okay. So here our 5s cancel out, and 35 divided by 5 is 7. So we get that x equals 7. Okay. So that's solving equations with rational expressions. Let's go through another example. Right. In this example, we've got 3 minus 6 over x equals x plus 8. Okay. So you notice here we have a different situation. We don't have just 2 fractions anymore. Each side of our equation has 2 separate terms, and only one of them is a fraction. We can still use the technique where we multiply everything on both sides by our denominators so that we can get rid of our fractions before we move forward with solving this. Okay. As you can see, the only denominator that isn't 1 is this x right here, right? Technically, this is a 3 over 1, this is an x over 1, and this is an 8 over 1. So we don't really need to multiply things by 1. We just need to multiply everything by x, and that will get rid of our fractions. You want to be very careful that you multiply the entire side by x on both sides. Okay, that's how the properties of equality work. You have to do it to both sides in their entirety. All right. So x times 3 is 3x. X times this 6x is going to give us 6x over x, which is just going to give us 6. Right? And that was our whole goal, was to get rid of that x in the denominator, and indeed we did. Over here, we're going to have x squared plus 8x. Okay, so we got rid of our fractions, but now what you need to recognize is that we have a quadratic equation here. Because we have this x squared term, we can't solve it just by moving all the x's to one side and all the constant terms to another side, because there's no way to combine our x squared and our x term, right? And we need to get an x in a single place. So what we're going to have to do is set this up like a quadratic equation where we set it equal to 0, and then we either will factor it or use the quadratic formula, okay? So if I want to get this equation set equal to 0, I'm going to have to subtract 3x and add 6 to both sides. Okay. That's going to give us a 0 on the left-hand side. And on the right, we're going to have x squared plus 5x plus 6. Okay. So we decided to set this equation to 0 because we saw that we had a quadratic, and so we need to solve it using quadratic methods, which are most often factoring. Sometimes you can do completing the square, or you can do the quadratic formula. There's a handful of quadratic solving methods, but factoring is usually the one you want to try first. Okay. So then to factor this, we want 2 numbers. They're going to multiply to 6 and add to 5. So that is going to be that's going to be a 2 and a 3, right? They add to 5 and multiply to 6. So now in this quadratic scenario, if either one of those 2 factors is equal to 0, it will make our equation equal to 0. This first factor will be equal to 0 when x is -2. So that's one solution. Oops, x equals -2. And the second factor will be equal to 0 when x equals -3. Okay. So the very last step that you want to do when you have rational equations is go back and check that none of your solutions make the denominator 0 in the original equation, okay? Because then it actually can't be a solution, okay? So let's go back to our original equation, where we've got 3 minus 6 over x equals x plus 8. And now our two solutions are that x is -2 and x is -3. And so we can just plug those in, and you see neither one of these are going to make the denominator 0, okay? And if we want to check that they both work, we can do 3 minus 6 over -2. Does that equal -2 plus 8? And so 3, this is going to become a 3 plus 3, which is going to be a 6. And on this side, we're going to -2, which is also a 6. So yes, that -2 works. And our -3 should also work, because it doesn't cause our denominator to equal 0. So we've got 3 minus 6 over -3 equals -3 plus 8. So this is going to be a 3 plus 2, which is a 5. And this is -3 plus 8, which is also a 5. So yes, that second one works also. Okay. Really, the only thing you have to confirm is that plugging in these values of x do not make any denominators 0, and they don't in this case. Okay. Let's do one more example. Let's say we have 2x over x minus 4 equals 8 over x minus 4 plus 1. Okay. So in this equation, the only denominator we have that isn't a 1 is the x minus 4. And that x minus 4 is its own factor. So what we're going to want to do is really multiply both sides of our equation in their entirety by this x minus 4. Okay. So on the left-hand side, we are, we just have this single term. So we're going to multiply this guy by x minus 4. And I'm going to put it in parentheses because I like to have everything in parentheses so I can see if I need to distribute or not. Okay. And then on the right-hand side, we're going to multiply everything by this x minus 4. And it's going to look like that. Okay. So on the left-hand side, the x minus 4 factors will cancel out. And we're going to be left with just the 2x. Okay. On the right-hand side, this x minus 4 factor is going to distribute to this term, and it's going to distribute to this term. Okay. So what that's going to look like is 8 over x minus 4 times, let's see, we're in black here, times our x minus 4 here, plus our 1 times our x minus 4. Okay, that's why we needed that second set of parentheses right here. Really indicate that this has to get distributed to both of those terms. So this is a term and the 1 is a term because they're separated by that plus sign. Okay. Now you can see that in this fraction on this side, our x minus 4s will also cancel out. Okay, but we are still stuck with that 1 times x minus 4. And that's okay because that'll distribute. So we've got a 2x is equal to 8 plus 1 times x minus 4 is just an x minus 4. And now that everything's just being added and subtracted, we can drop those parentheses and simplify on this side. You can see that the 8 minus 4 We've got an 8 and we've got a -4, so that can simplify to just a 4 plus x on this side. So let's go to a new whiteboard. What we've got now is 2x equals 4 plus x. We've got 2x equals 4 plus x. We'll use our properties of equality and subtract an x from both sides. So now we've got that x equals 4. So that seems simple enough, but remember, we have to go back to what was our original equation. Remember, our original equation is a 2x over x 4 equals 8 over x minus 4 plus 1. So this was our original equation. And now we have to ask ourselves, if we plug in that x is a 4, will it cause these denominators to be 0? And indeed, it will. So we've got 2 times 4 over x minus our 4 is equal to 8 over, sorry, that's not an x minus 4 there. That should be a 4 minus 4. There we go. A 4. So the x's are in blue and in parentheses. And then our original equation is going to be in black. So we've got a 4 minus 4 equals 8 over, again, 4 minus 4, because our x is 4, plus 1. So you see that this denominator here is going to become 0. This denominator here is going to become 0. So 4 cannot be a solution of this equation because this expression is undefined when x is 4, and this expression is undefined when x equals 4. Okay. So what we say to this is that this equation has no solution. And that's why it's very important to check the answer you get. Check that in your original equation and make sure it doesn't cause any denominators to be 0, because otherwise it is not a solution.